Okay, so in this video we're talking about the ratio of corresponding sides of similar shapes are proportional, including the shapes and its dilations. Okay, so the first thing I kind of want you to know is we are told that these two triangles are similar. And how do I know that? Because of that symbol right there. The little wiggly line that you see means similar, that they are similar. If there was two of them, then it would mean that they were congruent. All right, one is similar. And if you remember your old school definition, similar means same side, different shape. I'm sorry, let me rephrase that. Same shape, different sizes, okay? So both these are similar. They're both triangles, so they're the same shape, but they're different sizes. One is bigger than the other, all right? That's why there's one wiggle line, because they only have one thing in common. On congruent, it's the same shape and same size. So otherwise, that's why two of them are, because they have two things in common. The shape, they're both triangles, and size, they're both the exact same size. All right, so we're talking about similar ones, though, today. All right, and we're just kind of go. This is a definition thing. I just want to kind of, the way you read this is triangle ABC, okay, is similar to triangle XYZ. All right. Now they're telling you a lot of things just in this. I call them the directions. All right. These are what I call the directions. They're telling you that angle A and angle X are the same or similar. And if you look at them, angle A and angle X are both 64. When you have similar shapes, their corresponding angles are equal. It's only the corresponding angles. So corresponding angles are equal. So like B and Y. Well, here's B, it's 61, and there's Y, it's 61. And if you look at C and Z, they are the same thing. They're 55 degrees. Okay, so I just want to let you know about the angles. The angles are equal, congruent on similar shapes or similar figures, okay? So they're the same. All right, so another thing to kind of know is these, like I said, these directions are really powerful. They tell you a lot. All right, so in this, let me clean this up. So if you look, it's like how they draw it. So triangle ABC, they started at A, they drew a line to B, and then they go to C, and since they're telling you it's a closed figure, you got to go back to A. That's exactly how they're telling you this shape is drawn. All right. The same thing with triangle XYZ. Now, the AB part is your first line. So line AB is similar to line X and Y. So right here. So those are similar. So I could write AB, line AB is similar to line XY. All right. Another thing is that the second one, as you can see, is BC is similar to YZ. I'll put two little lines here. So BC is similar to YZ. That's our second line, that figure. Then our third line, all right, is CA. That means ZX. So this will be a third line. All right, and that's how you kind of put them together. If you're kind of like working on these as a ratio, you could set them up this way. You actually could set, which we are going to do on the next page. All right, so here we go. We know that triangle ABC was, DEF was dilated to triangle D prime, E prime, F prime. Okay, let's talk about the prime. The prime means that it's the new shape. New shape. If you have a double prime, that means it's been changed twice. It's the second change. And you could have a triple prime and all that. But if you don't have one, like here, this is the original. This is the first one. All right, so this is important because if you are looking at shapes, like we're looking at the two triangles here, we see some with just DEF and the other one was prime. So you know this one here is my original shape. This is my first shape. Now I know I drew these pretty close together so they don't look like they've changed very much. If they have, it's very little. But I'm just showing this is more of a teaching purpose. All right, so we have triangle DEF is similar to triangle D prime, E prime, F prime. All right, so I know DE is my first line. And I know DE prime is my first line. All right, I know that EF is my second line. And I know E prime, F prime is my second line. And you can see they kind of the way I drew it kind of turned the shape around a little bit. And then I know FD is my third line. So F prime, D prime is my third line. All right, so let's say I want to solve for one of the missing sides. Okay, and so let's say that we want to solve for E prime, F prime. Okay, so we want to solve for this guy right here. We want to know what this is right here. All right, so we already have E prime and D primes, so we need D and E. So we need line DE. All right, and then we're going to set it up to D prime, E prime. All right, over. Okay, so we did that. Now we need E prime and then F prime, so we have to have E and F on this one. All right, so let's fill in the numbers. All right, so DE is 30. D prime is 24. EF is 20. And we don't know what E prime, F prime is. So we could do our cross multiplication here. And that's going to be, it looks like 480. If I divide both sides by 30, it looks like my missing one is going to be 16. So this actually would be 16. And we can find D prime, F prime as well. I mean, we could go ahead and do it that way as well, doing the same thing. So basically, I just set it up as proportion. Now, I can find out how much this has been dilated by. All right, to find dilation, you take the new over the old. All right, so let's say 24. See, since prime is the new one, we're going to take the first one right here, and we're going to take the first one here. They have to be the same side. And we're going to say 24 over 30. If we reduce this, they're both divisible by 6, so it's going to be 4/5. So 4/5. So it's smaller. So otherwise, if the scale factor is less than 1, which it is here, it's 4/5, that means my shape got smaller. If it's greater than 1, of course the shape got bigger. So we know this shape got smaller. It barely got smaller. It's like 80%. It's 80%. So it didn't go down much at all. All right, so there it is right there.